let's begin. In part one of our series, we had a look at what Industry 4 is and how that's defined. So, of course, we invite you to go back to episode 1 and have a look at that if you haven't seen it already. But I'll give a 20-second overview here. The enablers of Industry 4.0 are a diverse set of technologies that all work together in an ecosystem. And these technologies are as diverse as cloud technology, robots, industrial cobots, augmented reality, virtual reality, machine learning, industrial Internet of Things, and of course, cybersecurity that underlies all of that. So all of these technologies work together, and they are parts of Industry 4.0 and the spectrum of that. The cybersecurity underpins all of these new technologies that are Industry 4.0. So in the field of fluid power, you might be thinking, well, which one of these technologies is relevant to us? Because hydraulics could be used on robots, pneumatics could be as well, but they're both fluid power. I could see some involvement there. Machine learning, can't really see that. Additive manufacturing, can't really see that. Well, the most relevant thing to us is the field of predictive maintenance. So with the predictive maintenance, the idea is that we're looking at these technologies, this ecosystem of technologies, and being able to apply it to machines. So this is where the cyber-physical world meets the real world, because we have real machines making real things in real industry. So one of the things that we can address is the long sought-after goal of asset reliability. So predictive maintenance works with the terms of condition monitoring, reliability, and machines as a service. These are the technologies that we can support and enhance with the Industry 4 group of technologies. So I'd like to talk about predictive maintenance. Predictive maintenance is ultimately, we are looking at a predicted future state of a machine. So this is a little bit different to what we have first is reactive maintenance. So reactive maintenance is the most obvious form of maintenance. When things break down, we're going to fix them, and that's when we address a problem. So that's reactive maintenance, and it's difficult to plan. It's difficult to have the right parts. A more involved and more correct maintenance strategy after that is preventative maintenance. And preventative maintenance is that we are going to do things at certain times to keep that machine in good running order. So things will be done at a certain machine hours or kilometers traveled, or of course calendar days. So that is preventative maintenance. And we're going to do things like change oil, change filters, remove varnish, whatever, change bearings and so on. Predictive maintenance is then an evolution of that. And the predictive maintenance is that you're looking at the current state of the machine, gathering data on that. You've also got a historical trend of the data from that machine in the past, and you apply the historical trend onto what you've got today, and then you can predict a future state. So time travel, that's Industry 4. So, and that is what predictive maintenance is. Predictive maintenance is something that's not new to HIDAC. We've actually been doing this for a long time, but realistically, for the majority of the time we've been doing it, it's been under a different name. So condition monitoring. So they're almost the same thing, but I would argue that predictive maintenance is different, and it's different because of the technologies Industry 4 brings to us. But first, I'd like to just show you something here. So with regards to asset management, I've got some wind turbines here. So we're heavily involved globally with wind turbine technology. In the lubricants and so on that are inside those nacelles. Now, so the companies that we support have been using our technologies to be able to assess the condition of these things for a while. Here is a magazine article. This is from March 2018, so it's a couple of years old already. So you can see here that the topics: predictive maintenance, condition monitoring, an enabler for Industry 4. So this was a magazine article that describes some of the products we have available, sensors, software, and things that will enable us to work with this as an idea. What I found interesting, though, is this is a magazine here that talks about condition monitoring, you see. So condition monitoring by HIDAC. And again, we're talking about sensors, we're talking about connectivity, we're talking about collecting information, grabbing that information, logging it, making it available to systems and making it available to operators, and then actioning service based on the information there, recording data and trending. So what's interesting about all of this is you can see here the date of the magazine. This is May 2007. So this is years before Industry 4.0 came up as an idea. This is well before the GFC. So we have been doing this for a long time, and it's not new. But what is new is the technologies of Industry 4.0, because they have fundamentally changed how we do this. And it hasn't made us any more successful than we've ever been. It just means that we can get access to that data anywhere, where in the past that was a little difficult in 2007. So we have a well-established strength here with the condition monitoring. It's something that we've always done. So Industry 4.0 condition monitoring, you put Industry 4.0 into the mix and that becomes predictive maintenance. Ultimately, the outcomes are the same. It's the connectedness that's new. Okay, so that's what's changed. And that's why Industry 4 has changed this condition monitoring and how that happens. So hopefully I've made that clear. So we now talk about predictive maintenance 24/7. And ultimately, the big change is that data isn't something that's just available locally anymore. That data we can get to the cloud, and with that, you can do anything with it. You can display it any way you like, anywhere you like, and do anything you like. And that's easy, and it's happening now. So predictive maintenance is basically your starting point is you're going to get information. And for that, you're going to need sensors. And how predictive maintenance works is it's not just a couple of gauges. It's not just looking at the machine data. It's looking at everything that you could possibly look at. So some of the technologies that have traditionally been used for condition monitoring are oil sampling. All machines have lubricants, certainly oil sampling for lubricating oils and hydraulic fluids. We're looking at the particulates, the solid particles. We're looking at the content of the water. We're looking at the viscosity. Certainly temperature is important there. The machine specifics then, the temperatures of the machine, the pressures of the machine, the flows, the speed, geopositioning even, vibration analysis. That's always been a big part of condition monitoring. Thermography, heat assessments, corrosion monitoring, acoustic emission analysis. There's many diverse technologies. Membrane patch colorimetry. We can use this technology to assess the varnish potential in an oil. And we can look at the product performance monitoring. In the case of manufacturing, we can look at the tolerances on the products that we're producing and so on. So there's many things that you can do, and all of this information becomes data. Where in the past, it's just been a diverse set of readings. With the cloud technology, you can collect all that, put it into one place, send it up to the cloud, and you can do cool things with it from that point. Okay, so I just want to give you a quick overview of really what the intention is here, of what we're trying to do. So because the reason I'm putting this into this presentation is because some of the people who are seeing this, the whole idea of condition monitoring and predictive maintenance may be new. So I just want to define that a little bit better. So if we have two things that we can assess here for a machine, the operating hours of the machine, how long it's been running for, and of course the probability of failure on that machine. So you can understand that, the longer you've been running a machine, the more likely it is to fail, because every machine will fail at some point. So the likelihood of failure, the probability of failure will increase over time. And you get to a point where you hit a mushroom cloud. This is your catastrophic failure. At this point, you can no longer do your job. The machine is not able to work, or it can't produce the parts with the tolerances that you require. So you really don't want that to happen, because there's all the possibilities of secondary damage occurring and so on. So we want to be able to stop catastrophic failure from occurring. Now, at the other end of the curve, at the start, we have also an increased probability of failure. So this has a terrible name. It's called infant mortality. So the infant mortality is when you have a new machine or a new oil, then that will be less reliable than an established machine and established oil. The interesting thing about maintenance is sometimes you can increase the probability of failure by doing some maintenance work. So sometimes the work that we do will increase the likelihood of failure once that machine's back online because of poor practices, poor tolerances, poor balancing, and so on. So the infant mortality, you want to avoid that area, and you want to avoid the area on the right-hand side, certainly. So the safest place to be with a machine is a really boring place where really everything's completely predictable. And that's what we're trying to establish. Now, what's interesting about the catastrophic failure and how that's going to occur is that we don't know the speed of degradation from the point of damage. So that could happen quickly or it could happen slowly. So ultimately, if you look at this in an overview, you have a potential life of a machine, and many things aren't going to reach their potential, just like me. So the probable life will be often smaller than the potential life, shorter than the potential life of the machine. And you've got then a point of damage and then the probable life. Okay, so you've then got a curve from the point of damage. So what you have is then the point at which you can identify damage has occurred and a point of failure. Okay, now being able to trend a machine and trend a history of a machine, you can get a history of how this is going to work in the future then. So this curve, this is the magic of how we do condition monitoring. It's called the PF curve. If you want to know about that, go to the internet. It's all over the place in about 10 different languages that all mean the same thing. And ultimately, it's about being able to predict that point of damage. If you know that, that's your magic. That's the point at which it becomes interesting, the point of your accuracy and the point of everything we do. So again, just to reinforce, we don't really know how long things will take to degrade, but we do know that we want to be able to detect the point of damage in between our sampling points, because otherwise it'll fail and we won't know why it's failed. So we need to have a repeatable and regular interval of measurement. So what we've done traditionally then is do manual condition monitoring. So that often involves somebody walking around taking readings. So I walk around given a task. Okay, today is my CM day. I'm going to take a reading on that machine. I'm going to take a reading. I'm going to write it down in the right place. Okay, because it might not be me that's analyzing the data. So we're going to collect all the information that's going to be relevant to us, and we're going to collate that information. And usually we're going to collect that, of course, on a PC. And what we very often do is prepare that in a graphical form, because humans aren't very good at interpreting a list of numbers in a table. We're much better at interpreting a graph. And with that, we can see a trend. And then we, as a maintenance crew, as a production team, whoever, we're going to make a common decision about what we're going to do with that machine, with any data, any trends that we're seeing. So that's how it works. In the world of Industry 4.0, we have online condition monitoring. So with the online condition monitoring, basically what we have is that information gathering is going to be happening passively. It's going to be happening in real time. It's going to be happening automatically. It's going to be gathered automatically, and it's going to be graphed, and it's going to be available widely. So all we have to do then is make a common decision on the trend, because steps 1 to 5 have been done correctly. So that is a much more efficient way of doing it. And this is why predictive maintenance and doing it online and using technology and connectivity, this is different to condition monitoring in the past. The interesting thing to understand here is that those steps 1 to 5, each of them are a point for potential error. You can get the wrong reading, write it down in the wrong place, and so on. All these things are points at which errors can occur. If the machine's collecting data automatically, the data is correct and it's not going to be misinterpreted, and it just is much more efficient. So always ask the question, is what I'm doing the most efficient way of doing it? I can't see anything more efficient in condition monitoring than online condition monitoring. So in 2020, this old manual condition monitoring and collection of data makes as much sense as this. Just a random point, one of my favorite bands just released a new album recently, and it came out on LP, which I always have questioned, but it also was released on cassette. Why would you do that? We know cassettes are bad. So why would you do manual condition monitoring? We know that's bad. We know they fail. So again, this is why we're asking the question, how successful have you been in your predictive maintenance journey? Okay, so these technologies, where can they be applied? Well, there's 4 different options available to us. Anyone who's studying industry would be aware of the automation pyramid, and the automation pyramid is something we discussed in episode 1, I'm pretty sure. But the first place that we can apply this condition monitoring technology is in data logging. So with data logging, essentially what we're going to do is collect information. The second option is we're going to display information. Is it going to be collected? It's going to be logged. It's also going to be visually displayed so it can be seen at the machine. So that's local monitoring, and that's no different to what we've always done with pressure gauges and things on a machine. But it's done electronically. The third option is process level monitoring. So this is a SCADA system or similar. This is a plant-wide monitoring system that machine is going to be monitored as part of a set of machinery, and that information will be available to us at a central location, and decisions are made from that point. And then the fourth option is the newest option, and that is remote monitoring. So literally you can do this stuff anywhere in the world. So it's those technologies, it's the industrial Internet of Things, the connectivity, the cloud, the machine learning, and the edge devices. All of these things put together give you much more versatility in how you collect the data, what you do with it, who sees it, where, when, how they access it, and how they respond to that information. And this is where we have products and solutions that are targeted just for those needs, because we are in step with Industry 4 and in step with the latest trends and the latest ideas here. So just looking at those 4 options, the first one is simply data logging. So of course we have data logging devices such as an HMG 4000 is shown here. So these are a service tool, and what can happen is a technician or anyone can go to a machine, hook up to it, take some readings, and this thing will not only show you what the readings are, but it of course will graph it. And you can log it, you can save those files, and you can compare an older set of data with a current set of data. You can do graphical overlays and things. So very, very useful tool. The CSI C11, this is a data collection device. It's a data logging device. It has its own WLAN, and you can log into the data and view it on your mobile device. So that's a Flumos mobile app. It will also, of course, send data to a computer and so on. So you can do many things with that very versatile device. ICMU 1000, this is again a data logging device. It'll collect information, but what's interesting about this one is that this will give you the ability to actually action some of the things that those sensors are going to see. So this is a programmable device. It's programmed with a free software in a graphical form such as this, and you can say that, look, if, for example, you see a particle count higher than this, you want to intervene and have that machine actually make decisions that are going to be self-repairing. You can turn on offline filtration, for example, if the particle count goes high, and once you reach a point where it's low enough, it'll turn it off again. So a very interesting device, that one. Okay, then. Local monitoring. So with local monitoring, we can do many things with that. Again, these are data logging devices. I've got one here. So this in the picture here, we've got a SMU. So this little guy here is something you just connect your sensors up to, and it's a combination of things, but ultimately it does give people what they believe they need, and that's the ability to see the data at the machine. I would argue that you don't need to. The people at the machine don't need to see that data. If it's being monitored remotely and people are aware of the way that machine is trending, you don't have to have the maintenance people run the show anymore. The maintenance people can be overseen by people that are reacting to alarms and things like that. But local monitoring data can be displayed on digital displays. Beyond that, as I said, is process level monitoring, SCADA systems and so on. So alarms are then handled at that level. So rather than be at a machine level, alarms will be monitored at a plant-wide level. Okay, so that is SCADA monitoring systems. So you can see here then that we have the process data that's been collected, interpreted, transferred, and then the monitoring and the control action, a service maintenance, and then go back to the machine. So this is all happening at a SCADA level. And then the fourth option of those four is the remote monitoring, the Industry 4.0. This is where it comes into it. So with current and emerging technologies at the edge, with the edge devices, the possibilities here are practically endless. And quite frankly, if you think you can do something with this data, with these devices, you can. If you can imagine it, the technology is there, you can apply it. You can have people be able to log into any machine anywhere in the world and have a look at exactly how that machine's going, where it is, what angle it's on, what heat the oil's on, what engine speed it's doing. And all of that data is, of course, getting logged as well. So that's a very, very capable set of technologies there. Okay, and that is really where the Industry 4 comes in. That then is the digital transformation. So one thing I've always said as the trainer is that we have the best toys. We've got some really fun stuff, and we play with that a fair bit in the training. So if you'd like to see how some of these devices work and see what we can do, have a look at our training, and we can get involved in that. Okay, so that's about all I'm going to cover today. So that's about it for today. I really thank you for your time. Thank you for joining in. We have part 3 of this one. That will be coming up shortly. I'd invite you to join in on that one as well if you feel this has been worthwhile. Until then, it's been an absolute pleasure, and wash your hands. Thanks.